Hello everyone. So from today we will see about next our fourth topic. It is related with the synchronous motor. Okay, as the name indicates, it's already we have seen in the last lecture about the synchronous generator. So next part is of synchronous motor. Okay, so we will see detailing about the synchronous motor one by one. So at the first we will say about the definition of synchronous motor. The motor which runs at a synchronous speed is known as a synchronous motor. Actually motor has a two type. First as a asynchronous and second was a synchronous motor. Asynchronous means the motor which does not rotate or does not run on synchronous speed, we call it a synchronous motor. Likewise induction motor. Okay, but for the synchronous motor, as the name indicates, the motor which runs at a synchronous speed is known as a synchronous motor. The synchronous speed is the constant speed at which motor generates the electromotive force. The synchronous motor is used for converting the electrical energy into the mechanical energy. This is the basic principle of machine or any motor. Now, synchronous motor means the name is going to synchronous motor because it operates on the synchronous speed. Okay, so firstly we will see about the construction of synchronous motor. Here, the construction of this synchronous motor is similar to that of your induction motor, three-phase induction motor. The stator and the rotor are the two main parts of synchronous motor. The stator becomes stationary and it carries the armature winding of the motor. Okay. Next, the armature winding is the main winding because of which the EMF is induced in the motor. The rotor carries the field winding. The main field flux induces in the rotor. The rotor is designed in two ways, that is the silent pole rotor or non-silent pole rotor. So the construction of this synchronous motor is similar to that of induction motor. Okay, because as we see in induction motor there is two main parts, stator as well as rotors. So in the stator part, actually in the synchronous motor in the stator, the armature winding or simply called the main winding is fixed in the stator side, while the rotor has a field winding. Now we will see about the working principle of synchronous motor. Okay, so we will say about the working principle. Now, as we know that the synchronous motor is work on the three-phase AC supply. It has a three-phase winding in the stator side. Okay, as the construction side, the stator has a main we call main winding or armature winding. So this stator part having a three-phase winding, while in the rotor, which has basically used the silent pole rotors. So this rotor has we are winding a field winding over this. Okay, the rotor मध्ये काय असतं field winding असतं. but इथं स्टेटरचा जो पार्ट आहे हा स्टेटरचा पूर्ण पार्ट मध्ये काय असतं मेन वाइंडिंग किंवा आपला थ्री फेज स्टेटर वाइंडिंग आहे. ओके, सिंपल कॉल्ड इज स्टेटर वाइंडिंग हियर and the rotor winding. Okay, and as we know the synchronous motor runs on the synchronous speed. Hence for this, now here what we are doing and what we are using for three phase AC supply or three phase winding, we are placed in the stator side, while the field winding is used or it is wounded on the rotor side. ओके, आता आपण इंडक्शन मोटर मध्ये काय बघितलं, इंडक्शन मोटर मध्ये स्टेटरला थ्री फेज वाइंडिंग असतं आणि रोटर मध्ये दोन टाइप आहे, एक तरी स्क्विरल केज रोटर किंवा स्लिप रिंग इंडक्शन रोटर. ओके, स्क्विरल केज मध्ये काही कंडक्टर असणार आहे, स्लिप रिंगला मात्र वाइंडिंग असतं. ओके, बट फॉर द सिंक्रोनस मोटर वी आर युजिंग अ स्टेटर as well as rotor. The stator having a main field winding, main winding, or as the rotor is having the we called this field winding, it is placed on the rotor side. Okay, now when a three-phase winding is fed by a three-phase supply, then a magnetic flux of constant magnitude but rotating at synchronous speed is produced. Because as we know that this is a AC supply, when we are applying a three-phase supply, what will happen, the current will flow through the stator side and hence the rotating magnetic field is produced in the stator side. Okay, now for this simplicity, just consider a two-pole stator shown in the figure. Okay, in which the two stator poles marked NS and SS, N and S. S and S म्हणजे काय, हा N, हा here N pole is there, here S pole is there. S indicates synchronous speed. Okay, sorry, it's a synchronous motor. Synchronous motors N pole, synchronous motors S pole. This small x, which is called a suffix x, is called a synchronous. Okay, this N and S pole. Okay, now for the simplicity, we are assuming that the consider a two-pole stator in which the two poles we called NS and SS rotating at synchronous speed. We are just assuming that the synchronous speed is rotating, or simply this rotating magnetic field is rotating in a clockwise directions. Okay. Now we are assuming that with the rotor position as shown, suppose the stator poles are at instant situated at point A and B. The two similar poles N of the rotor and NS of the stator as well as S and SS will repel each other, with result that rotor tends to rotate in anti-clockwise direction. That means what? Now just assume it. I am considering this figure. Okay. Now what will I have? This is a part of stator, as I said earlier. This is part of stator, while this is the part of rotor. Okay, the rotor having a silent pole rotor, and actually my winding is placed in the stator side. Now once I apply the three-phase AC supply to the stator side, what will happen? The three-phase current will flow through the stator side, and because of this three-phase current, the rotating magnetic field will be created in the stator side. Okay. Now what will happen? I'm just assuming that rotor position is likewise. The rotor मध्ये आता अशा पोझिशनला असं assume करा. Okay. That means rotor N pole, rotor, and here the rotor N pole, it is rotor N pole is at A point, while rotor S pole at a B point. Okay, here A and B point, for simplicity I am assuming that there are 2 points A and B. Just for a simple case I assume that my rotor having N and हा rotor मध्ये N and S pole कसा तयार झाला आहे, because as I know that I am connecting here field winding. Okay, and this field winding is always excited by DC supply. Okay, synchronous motor मध्ये जो field winding we are provided, it is always excited, it is always energized sorry by the DC supply. Okay, म्हणजे इथे माझ्या स्टेटरला माझा AC सप्लाय इथं मी कनेक्ट केलंय, बट जो रोटर आहे, रोटर मधलं वाइंडिंग आहे, इट इज ऑलवेज एनर्जाइज द रोटर सप्लाय, और द रोटर वाइंडिंग इज फेड बाय द डीसी सप्लाय. थ्री फेज एसी सप्लाय मी स्टेटरला दिले, रोटरला मात्र मी डीसी सप्लाय देतो थ्रू द ब्रश अँड कम्युटेटर अरेंजमेंट. Now for simplicity just assume that my rotor has just एकदा जर रोटर मध्ये करंट फ्लो आला लागला तर काय होणार, रोटर मध्ये काय ऑलवेज मध्ये डीसी मॅग्निट्यूड कॉन्स्टंट असते किंवा त्याचा चेंज होणार नाही, किंवा त्याचा म्हणजे आपण टाइम व्हेरिएशन्स काय नसतं, म्हणजे फ्रिक्वेन्सी 0 आहे डीसी ला. सो वन्स द डीसी करंट विल फ्लो थ्रू द field winding of the rotor, obviously what will happen, thus it will create the N pole at the rotor side, or here S pole of the rotor side. म्हणजे इथं N आणि S pole create होतात, ते obviously कुठला तरी N आणि S pole create होणार आहेत. So just assume that at initial position my rotor is at A position, that means N position or N pole of rotor is at A position and S pole of rotor is at B position. Okay, just assume that my N pole of rotor is at A position and S pole of rotor as a B position. Now at the same time what will happen, I am giving supply to three phase AC supply to stator and giving DC supply to rotor. Now because of DC what will happen, the pole is created, N pole and S pole is created on the rotor side. Similarly, while we are applying a AC supply, here also N pole and S pole is created by the AC supply or simple rotating magnetic field. Now what will happen, here N pole of rotor is at A position, while at A position what is there, NS or N pole is there, N pole of stator and N pole of rotor. Here S pole of stator, here S pole of rotor. That means just for this is assuming that in that cases N pole of rotor is located at N pole of stator, while S pole of rotor it is located at S pole of stator. Now as we know that both have similar charges, now because of this what will happen, the force of repulsion takes place between these two, that means N pole of rotor and N pole of stator, and repulsion takes place between S pole of rotor and S pole of stator, and hence because of this force of repulsion now the rotor tends to rotate in anti-clockwise direction. Okay, what I am saying, N pole of rotor, N pole of stator, S pole of rotor, S pole of stator, and because of this what will happen, the rotor tends to rotate in anti-clockwise directions. Is it? Now next period, but half a period later stator poles having rotated around interchanging their position, that is NS is at point B and SS is point A. Now what will happen, as we know that the AC is always changing, this AC is a sinusoidal waveform. Let at instant we are assuming that this A point is having N pole and B point is having S pole, but when the supply supply polarity goes in reverse direction, because I know that AC waveform start from zero, it will increase, again it goes decreasing likewise now. So suppose at the next instant, now what will happen, because of the stator AC supply, what will happen, this at a point what will happen, SS, that is S pole of this A point becomes S pole and B point becomes N pole. हे का चेंज झालं, आधी इथं A point ला N pole होता, B ला S होता, बट आता A ला S गेला, B ला N गेला, कारण का माझं AC वेव्हफॉर्म आहे ना, हे कंटिन्यू टाइम विथ रिस्पेक्ट टू टाइम चेंज होत राहणार आहे. सो बिकॉज ऑफ दिस व्हाट विल हॅपन्स at next instant, now here what will happens, this A position or A point, it become, or S pole is located at A and while N pole is located at B. Now under this condition, NS attracts S and SS attracts N. Hence the rotor tends to rotate clockwise. म्हणजे आता काय होणार, इथं N पोल आहे, इथं आता माझा आता रोटरचा काय झालं, माझा इथं रोटरचा N पोल आहे, स्टेटर रोटरचा S पोल आहे. नाव स्टेटर मध्ये पोल चेंज झाला ना एसी असल्यामुळे, इथं आता आधी N होता, आता इथं S झालाय, आधी इथं S होता, आता N झालाय. So because of this what will happen, this N pole will attract towards S pole of this N pole of rotor will attract towards S pole of stator, while this S pole of rotor will attract towards N pole of rotor. Okay, as N pole of rotor is attract towards S pole of stator, while this S pole of rotor will attract towards N pole of rotor. And hence because of this what will happen, because of this force of attraction, now the rotor tends to rotate in clockwise direction. Previously हे force of repulsion असल्यामुळे अँटी क्लॉकवाइज फिरत होतं, बट आता force of attraction झाला, मग आता clockwise मध्ये फिरायला लागले. That is, it is exactly opposite or reverse of that first direction. Hence we find that due to the continuous and rapid rotation of stator poles, the rotor is subjected to the torque which is rapidly reversing. That means what? My continuously my stator poles are changing. Previously it was N here and S is here, but right now S is here and N is here. Okay, म्हणजे आधी स्टेटरला N पोल इथं होता A ला, S पोल होता B ला, बट आता एकदम चेंज झाला, काय झालं, आता S पोल आला A ला आणि N पोल आला B ला. Okay, so because of this rapid changes in the pole of the stator side, now the torque that is in a quick succession, rotor is subjected to torque which is tends to move it first in one direction then in other direction. Firstly it may be rotate in clockwise direction, anti-clockwise direction, and second one laterally it will rotate on the clockwise directions. Now owing to its large inertia, the rotor cannot instantly respond to such quickly reversing torque, with the result that remains stationary. म्हणजे रोटरचा इनर्शिया असल्यामुळे काय होतं, सारखं माझा स्टेटरचा पोल विथ रिस्पेक्ट टू टाइम चेंज होत असल्यामुळे, एसी असल्यामुळे सायनसॉइडल वेव्हफॉर्म प्रमाणे चेंज, स्टेटरचा पोल चेंज होत असल्यामुळे रोटर एकतरी एका सेकंडला किंवा एका इन्स्टंटला क्लॉकवाइजला अँटी क्लॉकवाइज येईल, नेक्स्ट इन्स्टंटला क्लॉकवाइज आहे, हे कंटिन्युअसली चेंज होणार आहे. ओके, and because of but rotor has some inertia, and this because of large inertia of rotor, the rotor cannot instantly respond to such quick reversing torque, and due to this the rotor becomes stationary. That means we simply in other language we call it the synchronous motor is not a self-starting motor. Okay, synchronous motor is not a self-starting motor. What I said, synchronous motor is not self-starting, but by due to other means we should start the motor with the help of any other equipments. Okay, so this is nothing but the working of principle of the synchronous motor. As the name is given as synchronous motor, it always runs at a synchronous speed, and it has two parts, namely as construction as stator and rotor. Stator always has main winding which is supplied by three-phase AC supply, but rotor has only the field winding and it is supplied by DC supply. Okay, and this DC is supplied to rotor through the commutator and brush arrangement. Okay, and as with the help of the different diagrams, we can see the different working principle. That is, we can see the working principle of synchronous motor, why the synchronous motor is not self-starting. Now we will see about the method of starting of synchronous motor. As we know that the synchronous motor is not a self-starting motor, so the different methods are used to start the synchronous motor. Okay, so the starting of synchronous motor is there are basically two types. First is by using external prime mover, and second by using the damper winding. Okay, there are two methods. So we will see about one by one. So in the first part, we see about the motor starting with an external prime mover. Okay, external prime mover means the outer external device is there, prime mover is there. By using that, we will start. Okay. In this method, an external prime mover drives the synchronous motor and brings it to the synchronous speed, because as we know that synchronous motor runs at synchronous speed. Okay. Now in this method, the external prime mover drives the synchronous motor. Okay, that means the external prime mover is connected to the synchronous motor, and once the external prime mover is started, now it will brings the synchronous speed, a motor to synchronous speed. The synchronous machine is then synchronized with the bus bar as a synchronous generator. Okay, synchronous machine is then synchronized with the bus bar as a synchronous generator. The prime mover is then disconnected. Once operating in a parallel condition, the synchronous machine will work as a motor. That means what? Just here, at first, as we know that synchronous motor is not self-starting, so at first the motor is started with the help of any external prime mover. External prime mover connect करायचं, direct coupling करायचं किंवा connect करायचं and just motor run करायचं up to the synchronous speed. Now once machine is at synchronous speed, machine is then synchronized with the if the machine is get synchronous speed, then the synchronous machine is then synchronized with the bus bar as a synchronous generator म्हणून connect करायचं एकमेकाला, connect parallel connect करायचं. The prime mover is then disconnected. Once the motor is machine is synchronized with the bus bar, then the prime mover is disconnected. And once the operating in parallel condition, the synchronous machine will work as a motor. That means once we are connected to the bus bar as a synchronization, then the machine is work as a synchronous motor. Okay, and thus the load can be connected to the synchronous motor. And second part is of motor starting with the damper winding. First by using the external prime mover, second one by using the damper winding. Okay, so this is the figure of the particular rotor of the induction motor. The damper winding is the most widely used method to start a synchronous motor. A damper winding consists of heavy copper bars inserted in the slots of the pole faces of the rotor as shown in the figure. Okay, so whatever we have shown in the previous about the whatever the pole of the rotor, in the pole faces we are inserting the copper bars. Okay, हे पूर्ण तुमचा पोलचा फेस आहे. Okay, so we are inserting the copper bars in the pole faces of the rotors. Okay, these are the nothing but copper bars. Now these copper bars are short circuited by end rings at both end of the rotor. That means these are the end rings. These are these vertical lines are nothing but copper bars which is inserted into the rotor pole faces. Okay, and all these rotor bars are short circuited with the help of the end rings. Thus these short circuited bars form a squirrel cage winding. Okay, so as we know that the squirrel, as per the similar to construction of squirrel cage motor, squirrel cage मध्ये पण असंच होतं की ते पूर्ण रोटर कंडक्टरचा आम्ही काय लिहितो, एंड रिंग कनेक्ट करत होतो. म्हणजे सिंपली दिस विल ऍक्ट एज अ squirrel cage winding. When a three-phase supply is connected to the stator, the synchronous motor with damper winding will start. When the three-phase motor will connect it, obviously the rotor, this particularly synchronous motor with damper winding will start. It work as a three-phase induction motor, similar to that of a squirrel cage induction motor because of this rotor parts, and this is it will operate as a three-phase induction motor. As soon as the motor approaches the synchronous speed, the DC excitation is applied to the field winding. म्हणजे DC कधी अप्लाय करायचा आहे, नॉर्मली मोटर मला इंडक्शन मोटर सारखं रन करायचं. ओके, म्हणजे सिंपल इंडक्शन मोटरचं रन कसं होणार आहे, थ्री फेज एसी आपल्या दिल्यावरती काय होईल, ह्याच्यामध्ये as per the Faraday's law what will happens, Faraday's law of electronic induction what will happens, the current is induced in the rotor bars. रोटर मध्ये करंट इंड्यूस झाला काय होईल, as we know that एक रोटर स्क्विरल केजचं प्रिन्सिपल माहिती आहे की current carrying conductor kept in field experience of force and this will start rotating. Okay, and once the rotor approaches to the synchronous speed, the DC excitation is applied to the field winding. As a result, the rotor of the motor will pull into step with the stator magnetic field. Okay, and this is nothing but one of the most important method or most widely used method to start a synchronous motor, which is nothing known as a motor starting with a damper winding. So next part we will see about the different torques of a synchronous motor. The following types of torques are available in the synchronous motor. First, starting torque. Second, running torque. Third, pull in torque. Next, pull out torque. Okay, different torques are there. starting torque, running torque, pulling torque, pull out torque. So we will see one by one. So starting torque, it is the torque or turning effort developed by the motor when full voltage is applied to stator winding. Okay, it is the torque. Starting torque, सुरुवातीचा, starting means सुरुवातीचा torque. It is the torque or turning effort developed by the motor when full voltage is applied to the stator or armature winding. It is also sometimes called as a breakaway torque. Its value may be as low as 10% as in case of centrifugal pumps and as high as 200 to 250% of full load torque as in case of loaded reciprocating two-cylinder compressors. That means starting torque means what? It is the torque which is used to start the motor, which is called a starting torque. Next, running torque. As its name indicates, it is the torque developed by the motor under running conditions. Starting torque म्हणजे starting condition जो काय torque motor create करणार, motor फिरण्यासाठी किंवा start होण्यासाठी जो काय torque create होणार, we call starting torque. While the torque developed by the motor under running condition we call running torque. It is determined by the horsepower and speed of the driven machine. It is determined by the horse HP rating and as well as speed of driven machine. The peak horsepower determines the maximum torque that would be required for driven machine. The motor must have a breakdown or maximum running torque greater than this value in order to avoid stalling. Okay, stalling condition we have seen already in the machine induction motors. So this breakdown or maximum value should be more than this running torque. Next, pull-in torque. A synchronous motor is started as induction motor till it runs 2 to 5% below the synchronous speed. As we know that we are using a damper winding. By using damper winding, we are going to start our induction motor. So this induction motor normally, with synchronous motor normally we are starting with the help of induction as a induction motor. So if till it runs 2 to 5% below the synchronous speed, म्हणजे synchronous speed जोपर्यंत येत नाही तोपर्यंत आम्ही इंडक्शन मोटरसारखं रन करतो आणि एकदा synchronous speedच्या जवळपास आला तर आम्ही काय करतोय DC excitation देतोय. Afterwards excitation is switched on and the rotor pulls into step with the synchronously rotating stator field. कारण मला as we know that synchronous motor always runs at synchronous speed, but induction motor जसं स्पीडला रन होत नाही ना, synchronous speed इतकं फिरत नाही. Now to achieve this speed of the to achieve the synchronous speed to the synchronous motor, excitation is switched on. कधी जेव्हा मोटरचा स्पीड 2 ते 5% बिलो द सिंक्रोनस स्पीड येतो, म्हणजे नॉर्मली आपण इंडक्शन मोटर स्पीड तितकाच असतो. ओके, फुल लोडचा. ओके, सो आफ्टर एक्सायटेशन इज स्विच्ड ऑन, द रोटर पुल्स इनटू स्टेप विथ द सिंक्रोनसली रोटेटिंग स्टेटर फील्ड. द अमाउंट ऑफ टॉर्क ऍट विच द मोटर विल पुल इनटू स्टेप इज कॉल्ड द पुल इन टॉर्क. पुल इन म्हणजे काय, जो काय सिंक्रोनायझेशन व्हायला जो काय टॉर्क लागणार आहे, म्हणजे स्टेटरचा स्पीड आहे रोटेटिंग मॅग्नेटिक फील्ड, तो स्पीड रोटरचा स्पीड इतका मॅच व्हायला जो काय स्टेप किंवा जो काय टॉर्क लागणार आहे, कॉल्ड पुल इन. पुल इन म्हणजे आत ढकलणे, पुल इन. ओके, पुल आउट. द मॅक्सिमम टॉर्क विच मोटर कॅन डेव्हलप विदाउट पुलिंग आउट ऑफ स्टेप और सिंक्रोनिझम इज कॉल्ड पुल आउट टॉर्क. म्हणजे मॅक्सिमम टॉर्क, आता मागाशी भेटले की आपण रनिंग टॉर्क. मॅक्सिमम टॉर्क म्हणजे काय, तुम्हाला माहिती आहे की रनिंग टॉर्क मॅक्सिमम when the machine is rotating at a fuller speed, it will receive at a maximum torque. Okay, and the pull out torque means the maximum torque which motor can develop without pulling out, म्हणजे without unstable or without losing its control, whatever the torque which is called as a synchronous is called as a pull out torque. Normally when load is on the motor is increased, the rotor progressively tends to fall back in phase by some angle called as a load angle behind the synchronously revolving stator magnetic field. Through it keeps running synchronously. Motor develops maximum torque when its rotor is retarded by an angle of 90 degree, or in other words, it has shifted backward by distance equal to half the distance between the adjacent pole. Any further increase in the load will cause the motor to pull out of step or synchronism and stops. This simply काय, normally running condition ला आपण लोड वाढलं तर काय होतं, त्या proportion motor need to create the more and more torque. Now once we are increasing the load, you know what will happen, the torque on motor goes and current on the motor goes increasing, obviously torque is always on increasing, and now it will reach the maximum value, and up to that maximum value motor is now stable condition. Beyond that maximum value we call the unstable region, or we simply call it as out of synchronism or motor will stop. So that value of maximum torque, which is nothing but which is known as a pull out torque of this synchronous motor. So these are the 4 types of torque which are basically used for the synchronous motor, namely starting torque, running torque, pull in torque and pull out torque.